here. I just wanted to pass along real quick. I'm going to knock myself off the screen here in a second. Some of you are struggling, and that's to be expected. Most of you should be struggling a little bit. This is a hard class, and physics is not easy. It's not something that you can come and most of you are coming to class, which is great, and come to the lecture and expect to get everything you need out of the class to be successful. We meet for 14 and a half weeks about. So that's 29 class periods. 3 of those are tests. That's 26 class periods of 75 minutes each. There's absolutely no way on God's green earth I could teach you everything you needed to know to be successful in physics in that time. In fact, for the most part, I can teach you maybe 15% of what you need to know to be successful in physics. I probably should have given this little rah-rah speech on the first day of class, but you probably wouldn't have listened. Now you might be. Because, you know, especially if you're new to physics. And so in physics, we use mathematics, and that's just the way it is. That's the language of physics. And so there's an implied, I just turned on my ladybug because I'm getting ready to explain a couple of homework problems to you. There's an implied knowledge that, or it's implied on my part that you are expert at in mathematics up through, I would say, almost calculus 1, but at least college algebra and trig. I know the prereqs say this is algebra-based physics, so college algebra is all that's needed. College algebra to the pre-calculus package would be much, is what is expected, and that you're well versed in it, okay? And the other thing that makes physics hard is basically you've learned 4 equations in chapters 2 and 3. 4 equations, that's it. That's all you've learned. The rest is how to manipulate those equations to solve, to look at physical phenomenon and make predictions on where how it's going to turn out, how long it lasted, where it wound up, where it should wind up, all of it, neglecting air resistance and all those types of things. Okay, and so you've learned those 4, and then we've learned one other equation in chapter. Well, we've learned 2 in chapter 4. We've learned F equals ma, and you draw in all your forces, and we've learned the 2 static and kinetic friction formulas today very quickly at the end of class. So we'll talk more about those today in this sequence of videos. So to help you, like I said, we meet 75 minutes twice a week. That's, 150 minutes. You need another 400 minutes per week of physics to actually master it. Okay, I'll just tell you. There it is. It should be about a 2 to 2.5 for 1 study time. And study time is not looking at the homework problems, getting frustrated, then checking it and getting an answer and moving on. That is not studying physics. Studying physics is actually doing this, and I'm going to demonstrate some of the things that are in that you have purchased and that you should be using, okay, to help you do this. All right. So I'm trying not to make this a dad lecture. All right. But anyway, so here's when you go to Wiley Plus to the read, study, practice part, look at all this stuff you get. Look at all the stuff you get. You get physics demonstration videos. Let's go to chapter 4. Forces, Newton's forces, motion. So let's go to chapter 4. And here are chalkboard video. Here's ways to solve problem 32, problem 121. Let's take a look at it. I'm not sure what it does. So we'll hit enter. I mean, you can go to these places.
A spacecraft leaves Earth and heads toward the moon. We wish to find a point in space where the gravitational force exerted on the spacecraft by the Earth exactly balances that from the moon. This point will lie on the line connecting the centers of the Earth and moon. Let the distance between the Earth and moon be d. The mass of the moon is m sub m, and the mass of the Earth is n times the mass of the moon. Wherever the spacecraft is on its trip to the moon, the force on it will be equal to the vector sum of the gravitational forces.
So, you know, there you kind of get a like, is it helpful? Are you entranced by it? No, probably not. But it's at least a start on understanding gravitation, and then they go into detail on how to actually solve the problem and let you help out with it. And then there's concept simulations that you can use, that you can do. Here's one for static friction. So there's all kinds of, let me close this. Yeah, static friction, sure. Whereas, there it is, okay? And this is what we're getting ready to do today, all right? It's what we're getting ready to do today. So you put things in and you can analyze it and do those types of things if you want to, all right? So you got to get in there and play with it and those types of things. And so, but one of the main things, some of you that are like, I don't have time for all this. Well, okay, I hear you. So let's go back. Let's go back to the read, study, practice, the whole part here on chapter 4. Here's the other thing you can do. If all of this other stuff seems like just a bunch of bells and whistles BS, and I agree with you to a certain extent, I kind of like them. Why? Because I really know the material, so I find it interesting, the pedagogy that they're using and stuff like that. I think is actually pretty good. But let's look at Newton's laws of motion. All right, this is the actual book. All right, here are the equations that we're learning. Here is an example 2, applying Newton's second law of motion using components. You need to work that. You need to go through in the book and work every single example in chapter 4. Every single one of them. And then when you've done it once, you need to go back and do it again. Learning physics is just like learning how to play an instrument or learning music. Or learning to write well. All right? Because basically what we do as physics professors is it's the equivalent of an English teacher saying, well, here's the alphabet. It's only 26 letters. Go write Moby Dick. And that's basically what we're saying. That's the idea. There's 26 letters. Go write Moby Dick. All right? Now, how do you do that? Well, you practice. You learn how to spell first. You learn how to write a sentence. You learn how to write a decent paragraph. And then you learn theme and all that kind of stuff. Same thing in physics. Here's basically you've learned 6. If I count the frictional equations, you've learned 6 equations basically. And the rest we've just manipulated them with algebraic expressions. Okay? And so you go in here and you learn how to do it. Okay? They'll walk you through it and then you come back. This is like if you're getting ready for a recital. Some of you played piano, getting ready for a piano recital. These are your little finger exercises you're doing. These are those etudes you're playing over and over until it just becomes second nature to you. And then when you get a new sheet of music, like a new problem, you go, oh, well, I recognize the techniques for this, and you take it from there. Okay? I don't want to belittle the point, but that's how you succeed in physics. And there's no succeeding in physics without really trying. There's no sitting and memorizing the night before an exam. There's no looking at old exams and things like that if you don't understand what was being done on them. Okay? There's only one way to do it, and that is 3 hours a week minimum of practice. Good practice, where you're actually doing something that's helpful for you. Example 3, the displacement of a raft. There you go. And then answer these guys. And you can, and they give you, check your understanding. I'll bet $1 to a donut you might see these again. I don't know where, but you might. All right? We good? Okay.